Horizontal asymptotes of rational functions. The definition of a horizontal asymptote. The line y equals to b is a horizontal asymptote of the graph of a function f if f of x approaches b as x increases or decreases without bound. So, just like we've talked about vertical asymptotes, we're going to talk about horizontal asymptotes. So, let's look at some examples of horizontal asymptotes. Looking at this picture here, we see a graph is going on and on and on in the right direction. You see the dotted line. That's a horizontal asymptote. The graph will never touch that horizontal asymptote. This graph is getting closer and closer and closer to this horizontal asymptote, but this graph will never touch it. Okay? Now, let's read. It says, recall that a rational function may have several vertical asymptotes. By contrast, it can have at most one horizontal asymptote. Although a graph can never intersect a vertical asymptote, it may cross its horizontal asymptote, as in this example. If the graph of a rational function has a horizontal asymptote, it can be located using the following theorem. So, looking at this theorem that we have here, we're going to be able to determine whether a function has a horizontal asymptote or not. Alright, it says let f be the rational function given by, and we have the p of x over the q of x polynomial. Okay? Now, if you notice, this has f of x equals to a sub n x to the nth divided by b sub m x to the m. So we're going to be talking about this exponent of n and this exponent of m. These are your leading terms in your two polynomials. Now we're talking about the degree. The degree of the numerator is n, the highest exponent. The degree of the denominator is m, the highest exponent of the variable in the denominator. Number 1 says, if n is less than m, then the vertical asymptote is the x-axis. And we know the x-axis to be y equals to 0. Okay? So if n is less than m, then your horizontal asymptote is the x-axis, which is y equals to 0. Number 2, if n is equal to m, reading this, if n is equal to m, then the line y equals a sub n over b sub n is the horizontal asymptote. Well, if n is equal to m, in other words, if the two highest exponents are the same, then you have a horizontal asymptote, which is y equals to a sub n over b sub m. Well, that is the coefficients of the variables. So if these exponents are the same, then your horizontal asymptote will be the coefficients of the two variables. Number 3, let's read the last one. If n is greater than m, the graph of f has no horizontal asymptote. So looking at this one, if n is greater than m, then there is no horizontal asymptote. Okay? So there's your 3 little rules about a horizontal asymptote. Okay? That's your 3 little rules. If n is less than m, then the x-axis is your horizontal asymptote, y equals to 0. If n is equal to m, it's y equal to the coefficient divided by the coefficient. And number 3, if n is greater than m, then there is no horizontal asymptote. Okay? So let's take some examples and apply these rules in locating and determining horizontal asymptotes. So let's look at this problem. Find the horizontal asymptote, if any, of the rational function f of x equals 4x over 2x squared plus 1. Well, you look at the degree in the numerator is 1. The degree in the denominator is 2. This is the example of n is less than m. So if n is less than m, then the x-axis is the horizontal asymptote. And that is y equals to 0. So if your numerator exponent is less than the denominator exponent, remember this is n, this is m. If your numerator exponent is less than your denominator exponent, then your x-axis is your horizontal asymptote, and the name of the x-axis is y equals to 0. Remember, every horizontal line is named with a y, just a y. All right, looking at B part. G of x equals 2, 4x squared divided by 2x squared plus 1. Find the degree in the numerator, the degree in the denominator. The degree in the numerator is 2. The degree in the denominator is 2 also. This is the case of n is equal to m. Remember, when n is equal to m, you take the coefficients. You have y is equal to their coefficients. Well, the coefficient of x squared in the numerator is 4, divided by the coefficient in the denominator is 2, and 4 divided by 2 is 2. So your answer to the question of finding the horizontal asymptote for B part is y equals to 2. And then C part. Let's find the horizontal asymptote. Looking at the degree, this one has degree 3, this one has degree 2. In other words, n is greater than m. The numerator being n, the denominator being m. Looking at their degree. Going to that third situation, the third case, if n is greater than m, then there is no horizontal asymptote. So there's 3 cases. You have to memorize these. If n is less than m, like it was in this case, the numerator exponent is less than the denominator exponent, degree-wise, then y equals to 0 is your horizontal asymptote. If the two exponents, the highest exponents, the degrees are the same, you use the coefficients. 4 divided by 2, so y equals 2 was your horizontal asymptote here. I'm going to write HA, horizontal asymptote. And then the third case, when the numerator is greater than the denominator, there is no horizontal asymptote.